Welcome to EDU World Space.
Well, that's to show that ix times iy minus ixy squared is independent of the orientation of the x prime and y prime axes. So we can use Mohr circle here, and so we know that we have our center here, and we have some radius, and we have some new axes giving an area moments and area product giving these 2 points. So we know that ix prime, which is this value, is c plus r times cosine of 2 theta. Iy prime, again, we're just going to assume that this is x and this is y. We could flip them around or whatever, it'll give the same result. So iy prime is c minus r times cosine of 2 theta, since that's 2 theta. And ixy is r sine of 2 theta, okay, this distance. And so we can just plug this into our, say, take this times this and subtract this squared. And so this times this, the product of these two things is c squared minus r squared cosine squared 2 theta. Ix prime y prime squared is r squared sine squared 2 theta. And as we can see, we get sine squareds and cosine squareds. And that's why if we take this sum, we get that this is c squared plus r squared. And that is a constant. So no matter where we are in Mohr's circle, r squared and c squared are both constants, and so this value is a constant. And actually, it turns out that another way of looking at this is that this thing here is the determinant of the moment matrix, and the determinant is an invariant of the matrix, and so is the trace. The trace is an invariant, and the trace is actually 2 times c, right? Because the trace is ix prime plus iy prime, and that equals twice c, and c is a constant. And so the trace and the determinant are the 2 invariants of this 2 by 2 matrix. And so this is the second invariant here.